Dr. Stephen Ritz, the GLAST project scientist and astrophysicist from the Goddard Space Flight Center. And Joel Tumbiolo, the U.S. Air Force Delta II launch weather officer from the 45th Weather Squadron at Cape Canaveral Air Force Station. And we'll begin now first with Dr. John Morse. John?
Thank you very much. Astrophysics couldn't be happier about the launch of GLAST and the discoveries it'll make. We're really at a unique time in the history of science and of astronomy that we can study the cosmos across the entire electromagnetic spectrum for the first time. There have been many Pathfinder missions during the past decades, but here GLAST is one of those missions where we're extending our reach significantly. We already are able to study light out at the long wavelengths and low energies in the radio spectrum up through the infrared, the visible light that our eyes can see onto the ultraviolet, the X-rays, and then the gamma ray photons, which are what we would call the puffiest photons that tell us about the most extreme objects in the universe. When we do our portfolio in the astrophysics division at NASA, we receive community input on what our priorities should be, and that starts with our National Academy's decadal survey in astronomy and astrophysics. The most recent survey from 2000 recommended GLAST as the top-ranked moderate initiative, and we're very glad to be fulfilling that recommendation here. Another aspect of GLAST is the way that we're bringing a lot of communities together. First of all, we're bringing together the tools and techniques of the high-energy physics community with the astrophysics community in order to study the most extreme objects in the universe. We're also, as with most of our missions in the Science Mission Directorate, bringing together a collaboration among academia, industry, our government labs, and our international partners. And that collaboration is how we achieve success, because everyone brings a significant piece to the puzzle. And before I turn it over to my fellow panelists to tell you more about the space vehicle and the science, the particular science that GLAST will do, I want to say thank you to everybody who has worked on this mission. A mission as significant as GLAST takes a long time to come to fruition. There are people on this panel, there are people in the audience here who have been working on this mission for the better part of 2 decades and devoted their careers to making it a success. And so with that, I'll turn it back to you, George.
All right, thank you, Dr. Morse. And now to Omar Baez, the NASA Launch Director for Wednesday's launch. Omar?
Thank you, George. It's a pleasure to be here. We just concluded our launch readiness review for the GLAST mission. That was the culmination of our launch readiness reviews for this mission. I'm happy to say that we're looking forward to the launch this coming Wednesday, 11:45 a.m. And we're moving forward. The plan is for the tower to be rolled back tomorrow at approximately midnight. We'll be initiating our terminal count about 9 in the morning. We should have all the commodities on board by 11 o'clock in the morning and be ready to launch at 11:45. We've got a 1 hour and 15-minute window, of which we can probably only use about 60 minutes of that due to the time we keep the liquid oxygen on board. But all we need is that first second, and we're looking forward to it. If you could, there's a short video we could show you on some of the processing. This is the first stage booster. We are flying the heavy configuration for this particular vehicle. And this is these are unusual shots. You don't usually get to see this, and what we're doing is we're actually lifting and weighing the stages. All that plays into the final trajectories and so forth. We got to know the exact weight of the mass that we're flying up there. The spacecraft is particularly heavy on this mission. It's over 9,000 pounds. It's an SUV and a 20-foot boat behind it, if you want to look at it in real terms. Here's the gems going up. The way we do this is we hang those 3 at a time into the tower, and that whole tower moves up towards the first stage of that booster. And we end up doing that 3 times during this op to get all 9 of those gems around the core vehicle there. We started this op back in late March. It's now early June, so we've had plenty of time to work on this one. And like I said, we completed the reviews and we're really ready to go on this thing.
Ready? Go.
You can see the folks tightening up on those boosters. There's a lot of dynamic going on with all 6 of those solids going off at one time, all wanting to go in a different direction, and very large, massive attach points there. And this is the top of the second stage, and the spacecraft in its can being attached. We'll undo that can, get the spacecraft in a nice clean environment, and there's a nice view of the spacecraft there. And we'll put the fairing halves around it. This is the 10-foot composite fairing, and it's the first time we're flying this configuration out of the Cape here with the heavy launch vehicle. So you can tell a lot of work goes into encapsulating this spacecraft and making sure everything works out safely for this vehicle. As you've heard the past presenters, a lot of folks have put a lot of work and a major portion of their career into this, and we want to do it right. And with that, I'll pass it on to George.
All right, thank you, Omar. We'll go now to Chris Walsh, who's the Director of Delta NASA and Commercial Programs for the United Launch Alliance, and to talk some about the flight of the Delta. Chris?
Thanks, George. Omar's brought us to basically liftoff time of the 5th Delta II Heavy that we've flown for NASA, and as Omar stated, the first with the 10-foot composite fairing. I'm going to walk through the main events of the launch from liftoff through spacecraft separation, and then there'll be a short video showing the main elements. At liftoff, we have our Pratt & Whitney RS-27 ignite, and then 6 of the 9 solids will also ignite, and we'll take off from the pad. These heavy gems, they fire for 77 seconds as opposed to 60 seconds for a standard gem. And then after 77 seconds,